Section 7.1 here, we have what's called a null and alternative hypothesis. So here we're dealing with trying to predict what might happen based on different conditions here, what we might be able to conclude from it. So here we have some symbols that normally mean the null hypothesis versus meaning that we're talking about an alternative hypothesis. So here for the null hypothesis, if the statement isn't equal to, or it says that something is some number, you're dealing with equal to type of statement, and it could be in terms of the mean, could be a proportion, could be a standard deviation or variance, like we had in chapter 6. Then the related symbol for the alternative statement would be not equal to. So they're going to be opposites of each other. If the null is equal to, the alternative is not equal to. And the null will always have an equal to part. So for instance here, if it's a greater than or equal to, then the alternative would be less than. Or if it's a less than or equal to, then the alternative would be a greater than statement. So depending on what the null hypothesis is, will depend on what the alternative is, and vice versa. Depending on what the alternative depends on the null statement. So it depends on what we're dealing with here of exactly what we're going to have for those symbols. But you always have one set of values there in terms of it either equal to and not equal to, greater than or equal to and less than, or less than or equal to and a greater than. Those will always come in pairs there. So here, if we're looking at this one, example 1 was the one that we'll go through in this video. We'll do example 2 in the next one. We need to identify the null and alternative hypothesis for each of the following scenarios, along with whether the hypothesis is a left tail, right tail, or two-tail test, and shade the p-value area for each. So it looks like I forgot to include them here, so I'll type them up here. So the first one, let's say that it is stated that the mean length of a pencil is, let's say, 5 inches. And let's say that you claim it's more than that. So you think that the average length of a pencil is more than that. So if we're trying to write out, first of all, the null and alternative hypothesis here, what we have first of all are the symbols we have related to this. So for this null hypothesis, we get h sub 0 for the null. Null you can think of as a 0 there. And the alternative is h sub a. So we get h sub 0 for the null, h sub a for the alternative. So in this case, for our null and for the alternative, the following. So we write it out as h sub 0 and h sub a first, and then we have the colon mark. And in this case, since we're talking about a mean, we'll have the population mean symbol here. That's your symbol mu. Since we're talking about what we expect to happen for the population based on our sample. And in this case, we're claiming here that it's more than 5 inches. So the claim is normally what you'll write out first. Since it's more than, that's a greater than statement. It does not have an equal to part, so that means that claim has to go with the alternative statement in this case. So it's a greater than, in this case it's a more than, that means the claim is the alternative. It's one of those symbols that we have in the alternative column, which means that if that's greater than, the null has to be less than or equal to that value. And then normally we want to list which one was the claim, which was the alternative in this case. And then here they wanted to also shade the p-value area. So for the p-value area, that actually has to do with the alternative. So no matter which one's the claim, it's that alternative that you use to do the p-value area. So in this case, we had a value of 5 there. So it'd be this area out here for being greater than that, because the statement for the alternative was that the mean is greater than 5. So this value in here would be considered your p-value area. So that's in terms of that case. And then I have another one right out here to also go through. So for part B here, let's say that in this case that it is stated that the mean number of cars that are sold at a dealership in a month is, let's say, 30 cars. Let's say that your friend claims that the mean number of cars that are sold, sorry about that, I had another recording going that I was loading there. So your friend claims that the mean number of cars that are sold is actually greater than or equal to 30. So once again here, we're going to want to state the null and the alternative hypothesis here. So the null, remember, is the one with h sub 0, or HO. H naught is another way to say that for the null hypothesis. And then the h sub a is the alternative. Once again, we're talking about the mean here, so we'll have our symbol mu for the mean. And in this case, our claim of your friend was that the mean number of cars is actually greater than or equal to 30. So greater than or equal to 30, a greater than or equal to sign is the null. So that means the claim in this case is the null hypothesis instead. That'll also make a difference in terms of doing interpretations here later on as well, which we'll go through a little bit in example 2 once we get to that video. And if we have greater than or equal to for the null, the opposite of that would be a less than case. That would be the alternative. And like I said before, to do the graph for the p-value, it always has to do with that alternative. Whether the claim is the alternative or not, the alternative is what's used to do your sketch here in terms of your p-value. It'll also be used later on here as well in terms of determining what type of tail you have for the graph, if it's a left tail, right tail, or two-tail test, which we'll discuss more later on as well. So here our alternative is less than that 30. So this in this case represents your p-value area in this case. Go through how to go about calculating those once we get into section 2 later on.